Hello, in this video we are going to go over the solution of the problem 871, minimum number of refueling stops. So our goal is to find out how many stops we should have that we could start from the location 0 and then reach to the destination. The destination length is given to us. The target is that. So we have 100. So we are going to start from 0 and go to 100. And we have a couple of stations. For example, I have station 1, 2, all the way to station 7. These stations are located at different distance. For example, S1 is at distance 10 from me, or S4 is at distance 40, and S7 is at distance 90. Also, different stations can provide us different amount of fuel. For example, station 2 can give us 40 gallons. And our assumption is that we are going, when we go from the distance for each 1 mile, we are going to spend 1 gallon. So for example, if I spend from 0 to 10, I need 10 gallons of fuel to reach there. Also, we have a starting fuel which is given to us here. For example, that is 10. And information about these location of these stations and the amount of fuel are given to us in a grid like this. This is exact same things as what you see here. So for example, 10, 20 means that location is 10, 20 is the capacity of that station. Okay, now let's look at a possible solution. A solution like this. I can start at location 0 and I'm gonna have 10 gallons at the beginning because that is the starting fuel. And I can move for 10 miles to reach to the first station. When I arrive there, my tank is 0 and I can refuel that. And when I leave that station, the tank will be 20 because that was the capacity of station 1. Then we continue our journey and we can go to the next station, station 2. When I arrive there, the tank is 10 because I have to spend 10 gallons to reach there. And I had 20. Now it's 10. I get 40. The tank right now has 50. Then instead of stopping at 3, I can skip that and just drive to station 4. For going to station 4, I need to spend 20 gallons. So when I reach there, I have 30 gallons fuel remaining in my tank. At station 4, I can add 40, I get 70, and by 70 gallons of gas, I should be able to drive all the way to the destination. Because the distance from 40 to 100 is 60 and I have 70 gallons in my tank. So I don't need to stop at 5, 6 or 7. And when I reach the destination, the tank will have 10 gallons of fuel still remaining in it. So in this way, we can find the minimum number of refueling stops. For this example, it was 3. Station 1, station 2 and station 4. Okay, this is the minimum number of refueling stops, and now let's see how can we solve this problem. The solution to solve this problem is like this. 1. We imagine arriving at each station. So we don't have to go there. Just in our mind, we say, okay, if I be at 3, if I be at 4, if I be at 5. And 2, we check remaining tank. Okay. Then I say, okay, if I'm, for example, at S4, what is my fuel right now in an imaginary scenario? If it is positive, we say, okay, good, we can continue. But if it is negative, if tank is negative, it means that it is not possible to reach to S4. So I needed to stop before S4. So in that case, if it is negative, so it means that I needed to stop before that. But where I needed to stop? The first thing is that I needed to stop in a location that could provide me enough fuel. A location that could give me enough fuel. So for example, I'm at S4 and I see, okay, my tank is minus 20. So it means that I needed to stop in a location before that I could have 20 gallons of fuel in that station. Okay. The second thing is that as I'm going to find the minimum number of refueling stops, I want to stop at a location that I get the maximum amount of fuel. And when I'm at S4, not only that satisfy the minus 20 lack of fuel, but if I could stop at another station that I could, for example, get 40. You look at here. So we had S4 here and we have S2. I could have actually stopped at other places. For example, maybe I could stop at S3. Is that correct? So if, yeah, I can get here with 20, then with this 20, I had the possibility to just drive to S3 and then come to S4. But we didn't do that here. When we are at S4, we decided to get the fuel at S2 because that is where I can get the maximum amount. And look at here, when I'm at S4, the living tank is 70 and I can drive all the way to the destination. So that is the reason that we are trying to get the maximum amount of fuel. So we are trying to select a station to stop that I can get maximum amount of fuel. Okay, that's the other point. There could be a situation not only I have to stop at one station, I might have to stop at multiple stations. So I might have to stop at multiple stations. So maybe I get the negative 50 or negative 60 here, and I say, okay, in that situation, I needed to stop in 2 stations before this. We said that we are going to visit each node, and that would be the order of n. For example, here I'm at S4, and then at S4, I have to go and search all of the stations before that. So that is going to be lead to the n to the power of 2. And as the result, a naive solution will not be a good idea. But instead, as we showed, we are just need to get the maximum amount of fuel. We don't need to go and loop through all of these stations. I just need the maximum. And whenever we have a problem like this, that we just need the maximum amount or few maximum amounts of a list, that is where priority queues are going to help us a lot to save the time. So what we are going to do is that we are going to loop over all of the stations, and whenever I'm at the stations, instead of going and searching the stations before that, I'm just gonna go and use a max heap to give me the station with the maximum amount of capacity that I can use. Okay, let's start writing the code. Okay, we are going to write the code, and we know the inputs to the functions minimum refuel stops are 3 things. One is target, which is our destination. We have a start fuel, is the amount of gallons that we have at location 0. And we have the information of stations that are given to us. So we have 3 inputs, and we said that we are going to use a max heap. So whenever I'm going to use a max heap, the first thing we do is to import heap queue. Okay, now I'm going to start the heap, and I'm gonna say h, I'm gonna call it h, and we start that with an empty list. Then I'm going to define a variable called tank and put it as the start fuel for the beginning, and this is actually our arriving tank. And then I need a variable to record all of the stopping stations. I'm gonna call it resting locations. Now we can write a for loop to visit all of the stations. We said we are not actually visiting them, we are just imagining that we are at different stations. We say, okay, for current location and capacity in stations. So you know, stations has 2 variables. The first one is the current location and the second one is the capacity. First, let me also print these 2 variables. This is not going to do anything, just print out 2 variables for us in a nice format. Then we are going to calculate the amount of fuel that is in our tank at that location. And we say tank minus equals, because that is we are going to consume amount of fuel, and I want to know, okay, what is remaining in my tank right now. So for doing that, we just need to subtract the locations from each other. We say current location, that is the location right now I'm at that station, minus the previous location. So previous location. At the beginning we need to define this previous location as 0. Okay, the next thing that I'm gonna do is to update my previous location, because I'm going forward and every time I need the previous location, and previous location every time will be my current location. So I just need to say previous location equals current location. So we are updating the previous location. Okay, if we run this, so far this is like this. We are going to go and see all of the locations, and we have all of the capacities, and we calculate the amount of fuel remaining in our tank. So if you want, we can also print tank to see what is that. Tank so far. And we can see, for example, here, whenever I arrive at this location, tank is negative. So it is not possible without stopping before 20, I could reach to that. So, and that is true, because here you saw that S20, I have to stop at S1. It's not possible to reach here, because at the beginning we had only 10 gallons of fuel and the destination is 20. So that means that is negative. Now we are going to go and search the stations before that using a maxim, and for doing that we are going to do this. Then we start a while loop and say while h, if I have already a station in my max heap and tank is empty, and if tank is less than 0. In that case, what we are going to do is to pop from our heap queue, which is going to give us the station with the maximum capacity. So we are going to do this. When we are making a max heap, we are recording two informations in our heap. I'm going to call that as resting capacity, and the second variable that we are getting out of that is the resting location. So we get these two things when I remove the highest node in my heap or the max heap. Say heap queue dot heap pop and h. So I'm gonna get two variables. Okay, first thing that we do is to update our tank, because tank now we can increase the amount of fuel in that. So we say tank is minus resting capacity. So you might say, why is it negative here? The reason it's negative here is that in Python, the way that heap queue is working is designed for min heap, and whenever I'm going to use as a max heap, so all of the variables that we put inside we put negative, and all of the variables we take outside we consider its negative value. So when I'm pop from h here, this resting capacity, I'm gonna use the negative value here. So in that case, that will be the correct value. We will print them out and you will see what is happening. And after that, I'm going also to update these resting locations here. So we say resting locations dot append resting location. It's like this needs to be resting location actually. Okay, now we are done with our while loop, but there could be a situation that we are at the stations and we use the heap queue and we just use all of the stations before that, but it's not even possible to find any stations that could provide enough fuel for us. So in that situation, we are just gonna return negative one. So we are just gonna say, okay, this is not gonna work. So in that case, we say if after this while loop, if tank is still empty, if tank is negative, we just return -1. Then we are going to add things to our max heap. Things that we are going to add are current location and capacity here. So we say this, we say heap queue dot heap push. What to which heap we are going to add? To heap capital H. And what are we going to add? There are two things we add. So the first thing is the capacity. So we are going to say capacity. And the second thing is the current location. And as we are going to use a max heap, whenever we push something to H, we are going to push the negative value to that. So we say negative capacity. Okay, and at the end, I can just return the resting locations. I can also return its length. Okay, let's run it. And this is our solution. We need to stop at the stations 10, 20, 40. If we remember here, we stopped at the station 10, 20, and 40. And the length of us 3. So we need 3 stops. Okay, now let's start going over the code and printing out some middle sections. I'm printing the heap H, and also I'm printing the resting locations. And also I'm printing the value of tank. Okay, let's start from the beginning. So we said that we are going to imagine that we are at different stations. For example, the first station is S1. S1 location is 10. So the current location here is 10. And capacity is 20. So I'm at 10. When I'm at 10, the tank is 0. So we are good. So we don't need to have another stops before S1. We go forward. We go for S2. When we reach to S2, so for S2, current location is 20. We look at the value of the tank. Tank is negative. It means that I needed to stop before S2. So what I'm gonna do is to go and remove the highest node from my heap, which is this one. And by doing that, I put the location of that in my resting location. It says that I need to rest at location 10. Okay? And then I'm going to add the information of the second station to my heap. So now heap is updated to location 20 with a capacity of -40. Okay. Let's go for station 3. For station 3, location 3, we check the value of tank. Tank is 0. We are good. We don't do anything. We just add the information of the station 3 to our heap. Here. That is added. Location 30, capacity 10. Also look at the order. See what happened. First is -40 and then is -10, 30. Okay. Let's go for the next location. Station 4. For station 4, here, our location is 40 and tank is negative. It means that I needed to stop before that. And I look at the heap and say, okay, which one has the maximum value? And heap is going to give it to me. Say that is the one. So you needed to stop at 20. So I add that to my list of resting locations. And then we update the heap by adding the informations of station 4. The station 4 information is added. See what happens. Again, -40 comes to the top of the heap. Let's look at S5. Location is 60. We look at the tank value. It's 10. We still have fuels. We don't need to have another stops before that. So what we do is this. We just add the information of S5 to our H. So that is here. Just consider the orders, list what happens. So heap doesn't care about the order of these two. The only thing that it cares is this one. So it always keeps the max heap here. So that is the maximum one. So the order of these things doesn't matter. Let's go for S6 here. information about location is 80. What is the tank? Negative. Okay, we needed to stop before that. But where? Heap is going to tell us we needed to stop at S4, location 40. So location 40 is added now into the resting locations. This is our resulting heap. We just need to add the information of S6 right now to that. It's 80 and 10. It is 80 and 10. That is here. Okay, let's go forward for the next station. Station 7. Station 7, location 90. Tank is 20. We don't need to stop before that. We are good. And we can just add the information of that to our heap. So, which is 90, 20, that's gonna be here. Okay. And at the end, we are just going to return the resting locations. That is 10, 20, 40. The length of that is 3, which is the answer to this question. Okay, let's consider this example that we have different values for our capacities. Let's see what happens. We start from the location 10 again. Tank is 0, it's good. We go forward. Location 20, we fill out that. So we get H as minus 12, 20. And then we go forward. Location 30, we say, okay, we are good. Let's pass that. We go to location 40 and we say, okay, at location 40, tank is negative. And because it is negative, I have to pop from my max heap and use the capacity in that. So I can do that, and tank will be positive, and we go forward and we just add the information of 40 and 19 to our heap. Then we go at location 60, similar things happen. So we say, okay, tank is negative and I can pop from the heap, which is 19. That would be good enough, and I just need to add 60 and 13 to my heap. But at location 80, so our tank is minus 18, and if we look at the heap, the max heap that is we are going to get, the maximum capacity we get is 13. That's not enough. So even if I remove that minus 13, that is not enough. So what we do is that we go for the next possible available location in the heap. So we go and pop minus 11 as well. So both of them will be added to my resting location. So one of them was 60, the other one 30. So 60 and 30 are both added to our resting locations. So this is the reason that we had this while loop here. So it is not only one station that we are going to stop. Maybe in a situation like this, we needed to stop 2 stations before that. Okay, at the end of that, we are going to return the locations that we needed to stop. There are these locations. So we stop at each location except the station 7. Okay, now let's talk about time and space complexity of this problem. For the time complexity, we have a for loop here that we are going to visit all of the locations. So that's going to be order of n. Also, we have a heap push here that for each iteration we added the information to our heap. It's going to be order of log of n. Also, we could have heap pop here. That order for that one is also log of n. As a result, our total time complexity is n log of n. Also, we have the list h that we are recording all of the nodes, and at max it could need n locations, and we also had a list of resting locations that also could need n locations. So at max our space complexity would be order of n. Okay, this is the solution of the problem, minimum number of refueling stops, and thank you so much again for watching this video.